Hi there. All right, so today we're going to look at synthetic division. And synthetic division is basically just the shortcut way to divide polynomials using just the coefficients of the polynomials. So it avoids having to use long division, which could be lengthy and take up a lot of space on paper. Synthetic division, it's a new process, probably something that many of you have not seen before, but definitely once you get the hang of it, it goes very quickly and can get you that final answer pretty easily. So before we jump into it, there's a couple rules that you have to remember. So with synthetic division, your polynomials must be in standard form. So polynomials in standard form. And by that, I mean you want to put your highest power first and decrease from there. So x to the fifth, x to the fourth, x to the third, and so on. And you want to make sure that your polynomial, even if it's not given to you, is in standard form. The second rule is that you need a placeholder for all those powers of x. So you need a placeholder for all powers of x. So if you have a fourth degree polynomial, x to the fourth, then you either need, in doing the steps for synthetic division, to include a 0x to the third, or you need to have an x to the third in the polynomial. So we'll look at a specific example that explains that, but you definitely, before you start any synthetic division, want to keep these two rules in mind. So I think the easiest way to review or to learn synthetic division is almost to just look at a couple examples. Once you get a feel for how the process goes, you should be fine. So let's take a look at the first example. I have x to the fifth minus x to the fourth minus 9x cubed plus 13x squared minus 13x plus 3 divided by x minus 3. So again, remember, we want to confirm that A, our polynomial is in standard form. In this case it is, because it's x to the fifth is the highest degree, and that is first, and that we have placeholders for all the powers of x. So the easiest way to do this is just go down the list. I have x to the fifth, to the fourth, third, 3, x to the first, and then no x. So in this polynomial, I do have something in place for all of those powers of x. Okay, so before I go any further, I just want to define a couple terms. The term that you are dividing by, so in this case we're dividing our polynomial by x minus 3, that's our divisor. Squeeze it in there. Nope, not going to work. This is our divisor, and the other term is what we're going to call the dividend. So if we were setting up the long equation or long division process of this, the dividend would be on the inside of what I think sometimes call the house. So this would be our x to the fifth minus x to the fourth, dot, dot, dot. And the x minus 3 would be on the outside. So with synthetic division, we're going to kind of talk about inside and outside a little bit as well. And the divisor and the dividend are going to also go in the quote-unquote inside and outside. So how do we set up synthetic division? So to start, the first thing we want to do is take our divisor and just off to the side set it equal to 0. So x minus 3, setting it equal to 0, and then I want to solve for x. So x is going to equal 3. That 3 is what is going to go on the outside when I set up my synthetic division. So I put it on the outside in a little box. You're going to notice that the number that goes on the outside is always going to be the opposite of your divisor. But in order, as we get into other problems where maybe it's not x minus 3, but they're just giving you x equals 3, you want to just keep in mind it's always whatever x equals. So the first step is to set the divisor equal to 0 and solve for x. Okay, now our second step. Since we have placeholders for every power of x, the second step is simply to write the coefficients of our dividend down in a row. So we have x to the fifth, the coefficient there is 1, minus x to the fourth, so negative 1, minus 9x to the third, 13, negative 13, and 3. So I've taken just the coefficients of my dividend and I've listed them going across. Okay, so I've pretty much set up my entire synthetic division problem. I'm going to leave a little space between the line I drew and that top row. And now let's get into the synthetic division process. So you always want to bring down your first number. So this first number is always going to come down, regardless if it's a 1 or whatever it is. So I'm going to bring down my 1, and then my next step is I'm going to take my 3 from my divisor, and I'm going to multiply it by the 1. So anytime you have a number in this bottom row, it's going to get multiplied by the 3. So 3 times 1 is 3, and that 3 is going to go in the second row where I left a little bit of space. Okay, so I've multiplied 3 times 1 to get 3. Now I'm going to add the two numbers together. So when I'm working with the numbers in the first and second row, I want to add them together. So negative 1 plus 3 gives me a 2. Now I have a number in the third row. So again, I'm going to do 3 times 2 to get 6. That's going to go in the middle. And then I'm going to add the 2. Negative 9 plus 6 gives me negative 3. So as you can see, you're alternating between multiplying the numbers in the bottom row by 3. So we're going to multiply, and adding the rows, the first and second row together. So this process continues until you get to the last number. So if we continue this, we have 3 times negative 3 is negative 9. Then 13 minus 9 is going to give you 4. 3 times 4 is 12. Negative 13 plus 12 is negative 1. And 3 times negative 1 is minus 3. 3 minus 3 is 0. Now it's worth noting this last number in this last box where the 0 is going to be our remainder. So in this case, the remainder is 0. Okay, so when our remainder is 0, we don't have to worry about it, but we'll look at an example for what we do when the remainder is not 0. Okay, so we now have almost our final answer. 1, 2, negative 3, 4, negative 1. Those are going to become the coefficient of our final polynomial, because remember, we're dividing polynomials, and so if we're dividing a polynomial by a polynomial, our final answer needs to be a polynomial. So in order to get our final answer, when we put the coefficients up at the top, we basically removed all of our variables. Now we're going to put them back, and the way we put them back is we look at the degree that we started with. We started with x to the 5th degree, okay? Our answer will always be 1 degree less than that. So if we started with x to the 5th, down at the bottom, this 1 is actually going to be the coefficient for x to the 4th. And then we decrease powers of x from there. So then the 2, it's going to be plus 2x to the 3rd minus 3x squared plus 4x minus 1. That ends up being your final answer. So our polynomial x to the 5th minus x to the 4th minus 9x cubed plus 13x squared minus 13x plus 3 divided by x minus 3 equals x to the 4th plus 2x cubed minus 3x squared plus 4x minus 1. So as you can see, the setup is pretty easy, and then you're multiplying or adding as you move down the row to get to that final to get to the final remainder, and then you're putting your variables back using a power less than what you started with. So I know it's a lot of information. We're going to take a look at another example, and we'll go through the process again step by step. So let's take a look at the next example. X to the fourth minus 8x squared plus 6x minus 7 divided by x plus 1. So again, the first thing we want to remember is that we need to make sure the polynomial is in standard form, so highest power first, and that we have a placeholder for all our powers of x. So the first rule, we have x to the fourth, so we are in standard form because that's the highest power, but you'll notice there is no x to the third. So when I write my coefficients across the top here, I need to put a 0 in for that x to the third placeholder. So we'll come back to the divisor here, but I have 1x to the fourth, right? This was x to the fourth. Then for x to the third, I don't have anything in my polynomial, so I'm going to put a 0. Then for x squared, it was minus 8. For x, it was 6. And then the constant is negative 7. So the important part here is you need that 0 for the x to the third, even though it doesn't appear in your original polynomial. Okay, so I'm going to go off to the side. I'm going to take my divisor, x plus 1, set it equal to 0. Solve for x, so x equals negative 1, and that's the number that's going to come on the outside here in my box. So draw my line, leave a space for a second row. Remember, always bring down the first number. And now we are going to multiply the numbers on the bottom row. So negative 1 times 1 is negative 1. That goes in the middle. And then I'm going to add rows 1 and 2. So 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. Negative 8 plus 1 is negative 7. Negative 1 times negative 7 is 7. 6 plus 7 is 13. Then I have negative 13. My remainder ends up then being negative 20. Okay? So I now have the coefficients for my final answer, remembering that I started with x to the fourth, so that my final answer is going to be an x to the third. So this is x to the third minus x squared minus 7x plus 13. And you'll notice in this problem, I have a remainder. My remainder is going to be part of my divisor. So the way I write that into my final answer is, I'm going to say minus 20 over my divisor, which is x plus 1. So my final answer is x cubed minus x squared minus 7x plus 13 minus 20 over x plus 1. So hopefully you're starting to get a feel for the process of synthetic division. As you can see, it actually is not very many steps. You can get that final answer a lot easier than if you were doing long division. It's just a different process that you probably have not seen before, so it's just getting yourself familiar with how that process is. All right.